So can you see the same thing on the screen? Yes or no? So this is actually today's notes. Aldia is responding.
Yes.
See, she gave a thumbs up. Very good. Okay, Aaron also responded. Good. So you can actually take a look at the slides for today. Yeah? Okay, these are the notes for the lesson. So other than doing this, all right, I would want you to click on this cloud icon here. Can you see? It says download. Click on it so that you get a copy of this in your computer. Ken, have you all done that? Because this is not going to be here for a long time. After probably about 7 days, okay, I will be removing this. All right, so the online flipbook will not be there all the time. Have you done it? Give me a thumbs up if, let's say, you have completed the download. Good, thank you, good. Okay, so we're going to start with our lesson. Let's go to our slides. Okay, can you see my slides now? Let me know. Pei Ying can see my slides now. I'm at the PowerPoint slide. Okay. Anytime you have questions, let me know. You can put up your hand. You can speak over the mic. You can also type in the chat. Haley Ray, thank you. Right, so today we are going to go through atoms and molecules. How many of you, honestly, you have watched the e-learning video? Good, hey. Brian, did you do it? Have you watched? No? Okay. Today, Brian, you are having your trial lesson, right? Yeah, so this is what you need to do, Brian. Okay, before you come for the lesson, you watch the e-learning video. Okay, so you roughly know what the topic is about. If it's a new topic, then you can expect certain teaching. So I'll be teaching a bit for today. Okay, quite a bit actually. I won't be rushing through the worksheets. Yeah. Okay, I won't be rushing through the worksheets. I will be focusing more on the teaching part. And then after that, we will go through the questions. So Brian, have you done the worksheet also? Like the rest, did you do it, Brian? You didn't, is that? Okay, later you let me know whether you're having any issue because you're new today. So you might have certain issue regarding the questions. Okay, Bernie, have you done it, Bernie? Let me see.
Yes.
Okay, yes, that's right, you did. I'm just checking the responses. Good. 1, 2, 3, 4, 5, 6 of you did this. Okay, the rest didn't. Right, okay, so let's start now. Atoms and molecules is not something unfamiliar to you. Actually, earlier part of the year, we did talk about this. Okay, when you're doing the mixtures, elements, as well as the compounds. Do you still recall, Hein? Yeah, we have all the diagrams there, right? So we have to identify, whether they are molecules of the elements, molecules of compounds. Yep, good. So we also talk a little bit about the periodic table. Today, we're going to go to the periodic table again. Now, so for atoms and molecules, you have 3 points on the first slide. Okay, you need to describe an atom as an electrically neutral entity that is made up of a nucleus with electrons moving around the nucleus. So you're going to look at it later in detail because I'm going to teach you probably a little bit more than what you will be learning in school. Show an awareness that atoms of the same element contain the same number of protons. Okay, and later you'll also learn that it's not just the protons that are the same for them. It is also the electrons. Okay, so as well as the electrons. Recognize that an ion is formed when an atom gains or loses electrons. Now, so the next part you will need to know also another 3 points. Show an understanding that molecules of an element consist of a fixed number of the same type of atom combined together. So this is the part you have learned before. Okay, I'll be asking you questions later. Let's see whether you still remember what was taught. Okay, show an understanding that molecules of a compound consist of a fixed number of different types of atoms combined together. Then state the number and types of atoms given the chemical formula of a compound. So let's say I give you this particular compound. Okay, this is the chemical formula, right? So if I ask you right now, do you know the number and types of atoms? Okay, how many of you can actually answer this one? If I ask you right now, how many atoms, how many types of atoms do you think you can give me an answer? Anyone wants to try?
Me?
Oh, okay, good. Aaron, try.
5 atoms.
5 atoms. And how many types are there?
3.
Did you say 3?
Yeah.
Okay, so you say 3 types, right? So do you think you can tell me what are the 3 types?
I don't know. I don't know Ca, but carbon and oxygen.
Okay, so you're telling me that there is actually Ca, and then there is carbon, and then there is oxygen, right?
Yeah.
Very good. Okay, so the types of atoms refer to the elements also. Where can you find elements? Where can you find elements? If you, let's say, want to find something about the name or the chemical symbol, where can you find them? Anyone knows? Very good, Hey Yin. Okay, periodic table. Can still recall? If you look at your notes that I've just sent you, can you flip a few more pages? You should be able to see the periodic table. Are you able to find that? Bernie, can you find it?
Yes.
Good. Okay, so from the periodic table, you can even know their names. So you go and refer to the periodic table if you're unsure. Okay, Aaron, you don't know what Ca, right? Ca is calcium. So you go and look into the periodic table. Can find the name there, right?
Yeah.
Okay, good. Right. He's right, because for calcium, okay, there's actually 1 atom of calcium, right? Okay, and then 1 atom of carbon, and then 3 atoms of oxygen. So total, it makes 5. Okay, but there are just 3 types of these atoms. Okay, right. Li Rui, good question there. You said that CO, isn't it cobalt? If you look very carefully, okay, look very carefully at the periodic table. I also have the periodic table here. Okay, maybe I'll just go quickly to the periodic table first since you brought this up. Okay, where did you see cobalt? Can you all find cobalt here? Very good. So look for number 27. Yes, this is where cobalt is. Okay, this cobalt, take a look. Okay, it's a capital C and a small o. Right or not? Just now, when I show you calcium carbonate, this is a capital O. This is a capital C. It is actually carbon and oxygen. That's why the way you write your formula is very important. Understand or not? Remember, I think Hey Yin, Aaron will remember very clearly because you have been with me for a long time, right? So
I guess.
you need to know, okay? For example, chlorine. I told you that chlorine is a Cl, right? Why is it that we don't write it this way? Because this can mean C and capital I, right or not? So we must differentiate. Some of you will be writing your Cl this way, or you can see the books, or your teacher writing this way. It's fine. Just avoid writing it this way because the I seems to be capital. Or should I say that this L looks like I, which is a capital letter. Okay, of course, some of you will be wondering, how about iodine? Okay, we will advise you to put iodine or write iodine this way. It's a letter I only. Okay, now I also mentioned if let's say the chemical symbol consists of two letters, the first one must be capital, the second one is a small letter, just like calcium. You see the A as a small letter, right? So it's a small letter for calcium. Sodium as well. Okay, you have capital N and then a small a. Okay, many of them also like this. So you always see that the first letter is a capital letter, the second letter is always a small letter. Li Rui, you understand better now? I answered your question, right? Good. Okay, so I'm going to erase all this because later on, I'll be talking a bit more about the periodic table. Okay, so let's go back. So what is an atom? You need to define atoms, right? You need to know how to write this down yourself. It can be tested in the open-ended questions. So write down, atom is defined as the smallest particle of an element that can exist, and they are the building blocks of all matter. Okay, and then inside an atom, right? Okay, you can find protons, neutrons, and electrons. Okay, and then you need to know something about the protons. They are positively charged. Okay, neutrons are neutral. Electrons are negatively charged. And later on, we'll be doing certain working. All right. Protons and neutrons make up the nucleus of an atom. That means they are located there. They are found there only. Okay, for example, you can see here. Okay, this is where the nucleus is, right in the center of the atom, right in the center. Sounds a little bit like the cells, right? There's a nucleus inside. Okay, but these are atoms, not cells. Then you will see also the electrons are actually found in the electron shells. Why I mentioned electron shells, later you will see something as well. You'll learn something new. Charmaine is here. Okay. Let me take attendance for her. Okay. Hi, Charmaine. Charmaine, can you hear me? I just sent this link in the chat. Can you click on it and then download today's notes? Okay, Charmaine? Oh no, she's out again. Okay, never mind, we'll continue. I will send to her later. All right, so again, this is how roughly the atom looks like. It's just a representation of the atom, okay, where you have the nucleus right in the center consisting of protons and neutrons. And then we have the electron shells, and these are where the electrons will be found. Okay, so since protons are positively charged and neutrons are neutral, we will say that the nucleus is actually positively charged. All right, electrons, see, found in the electron shells, they move around the nucleus. They are extremely small. Okay, and then they have negligible mass. Next part. Okay, protons, right, found in the nucleus, positively charged. Neutrons found in the nucleus, neutral, carry no charge. So I write the charge as 0. Okay, and then for the electrons, right, they are negatively charged particles moving at high speed around the nucleus. Wait just a minute. Charmaine has been kicked out again. Right. So can you see a +1 charge here? That means every proton carries a +1 charge. All right. And then for the electrons as well,